kind of initiations we did at Patnaik University of Engineering. During my stay at NAC, Bangalore, I witnessed the National Education Policy documents. In 2023, we initiated the process of implementing NEP. Of course, this year the higher education department has implemented, except academic based of credits and multiple entry and multiple exit. The schemes and other things have been implemented in technical education of the entire state. We have 3 universities, BSSUT Kurla, OUTR Bhubaneswar, and Patnaik University of Technology. We started with, we had a curriculum conclave, we developed the curriculum, we had a research conclave for research scholars, we have project exhibition for BTech projects, we have BPUT Hackathon, BPUT Industry Academia conclave, and this year, December 19, 20 and 21st, we are organizing the first international multi-conference at Patnaik University of Technology, Odisha. These are the initiatives we did, and the best part was I understood like the examinations and result declaration was a problem. I thought I will use some kind of whatever knowledge I had in computer science and engineering. I like the subject computer architectures, pipelining, just I use pipelining, simple concept of pipelining.
इंटेलिजेंस बहुत गुड़ाक कम कर मशीन को केमती आम इंटेलिजेंस कर गोटे फैकल्टी डेवलपमेंट सारा भारत वर्ष कहली आसी विभिन्न जगार फैकल्टी मैंने आसी ट्रेनिंग दि जामर अल्टीमेट आम चाहूँ पिला माने केमती ट्रेनिंग पाइबे।
Very good afternoon to all of you present here.
And innovations in the field of AI. Let this event be a stepping stone for many more collaborative efforts, research ventures, and applied projects. I extend my heartfelt thanks to our
such as machine learning, deep learning, natural language processing, ethical AI, and many more. So on day 1, that is on 15th June, the FDP began with an inaugural session, followed by the first technical session conducted by Dr. Professor of IICTE-ATAL, who introduced the theme role of AI, data to intelligence. In the afternoon session, Ms. Hon'ble, Deputy Manager at Official Bhubaneswar, delivered a session on the integration of AI in energy transition. The day concluded with an article discussion on wavelet fuzzy hybridization techniques and a hands-on lab session. We are marching ahead. So for this, initially there was a proposal that once we got the NAC accreditation, then the accreditation of the department, it was our target that to must get certain funding from AICTE. And with the approach of Madam and Aravind sir, we tried to go ahead and the proposal was set in time. So for that reason I must congratulate thanks Smita Madam and also Aravind sir and the cooperation of the department, particularly electrical department.
I would like to thank to the organizing team for giving me an opportunity to stand before you again. As a chief guest of this valedictory session. You know, since array of speakers have already told many things about this FDP as well as a list of participants have already given feedback, very interesting as well as useful and also need of the hour. You know, the artificial intelligence, you know the objective of artificial intelligence. The objective is very clear that the moment you learn artificial intelligence, you should keep in your mind that you are going to develop a machine that can act and think like a rational human being. So this is the whole objective of artificial intelligence. And you know this artificial intelligence, the topic of interest, is penetrating every sphere of our life. And we need to use
your work on what is it, how it works, what for I am working. Anybody has any experience that on working the remote sensing images? Okay. We'll start from here. What is artificial intelligence, machine learning, pattern recognition, data mining, whatever just now I was talking about. Okay. So a brief understanding about all these things we need to first know. Before same axis going to two systems. So this is called systems H1 and H2. System, you are understanding, no? Yes. A machine or something which takes input. So there are two systems, H1 and H2. When X is going through H1, it is giving you Y1, and same X is going to H2, it is giving you Y2. When H1 is same as H2, what do you say about Y1 is? Taking decision is not so big. Taking decision is not at all a big problem. Taking decision is not at all a big issue here. It's very easy to take a decision. Then what is difficult here? What is difficult here? That's right. Same problem. The 10C high number of solutions. So solution, there is no depth of solution. There is no non-availability of solutions. So many solutions right now.
So these are the illustration of these two kind of signals. So it's a continuous time, continuous amplitude signal. This is a discrete time but continuous amplitude signal. But also amplitude can be also discrete. So next process is processing. Okay, so these are the basic idea about what is a signal. Now, why we need processing? Because signal is there. Why we need so much processing? Because we want the information content in the signal to be utilized properly. So, signal processing is the science and technology of analyzing, modifying and interpreting the signal. Okay, so you have to analyze the signal because what are the information present in the signal that we have to extract and we have to measure of the signal. We want to decorrelate as much as possible with the variable. Suppose at what time, what frequency is present, we are not able to understand in time domain. We can only understand what is the time
at that time what is that. Similarly, in frequency domain, we can understand at what frequency what is the amplitude. But we cannot understand at this time what frequency is present and what amplitude is present. All three combinations for that. Similarly, time frequency analysis is required.
These are all real life lessons. So let me know before, like we can also rewind whatever we learned, and whatever we learned, all that application. Many examples I have given, same thing you will see, but we'll try to go in deeper in each of these. All these are like proven case studies from topmost companies. Okay, it might be in something finance, or it might be in internet technology, e-commerce. Okay, so let me know any doubt in the whole theory part. No? Okay, fine. Okay, so here's the first one. You all know what Siemens, right? So predictive maintenance, I was talking just before a minute. Just read the problem statement. If you have pen and paper, so we will try to solve it in here the crisp TM, right? But there we will try to focus on 4 parts. One is like what is the data required.
And then we have downloaded that code, compiled code in the form of bit string into the chip, and the all CLBs within that chip gets configured like this. So what it is doing, it is storing means the orange, the first unit is doing the pixel sum in column wise or row wise, only sum of the pixels up to that row or up to that column. And then the new row will be added or new column will be added. So that is done by these integral operations. And these out of these integral operations that is stored in an integral memory. And in that also we have reduced the number of memory locations. So for an n cross n image, we are dividing it into W cross W blocks. So in that
process of mail fill level estimation through okay, yes, we have captured vibration signal, then we have done FFT, then feature extraction through ANN network. We can tell the percentage fill level. This is we have published in neural computing and application. Then another problem, we have developed another system, online moisture monitoring system. You have heard about the inaugurated moisture sensor, but we have developed micro, more color, then more subtly, less color, lightish color, less subtly. That's what is going on. Okay. So we have demonstrated some people and everything. So conclusion. Instrumentation in linear processing can be improved by using AIML techniques. Okay. Attempts were made to use conventional sensor like accelerometer, camera, temperature sensor, etc. to collect data. How do you need the data? You need impedance will measure. Will see where more material, more impedance.
One group is a very studious group, another group is they are doing some mischievous works. So the members in that particular group will be by default told as that they are mischievous in nature, they are very good in nature. It may happen that one of the student may be studious, but as they are in a group, we will assume that these are the mischievous students. Similarly, here is also the scenario. We have to find out k number of nearest neighbors. These nearest neighbors machines health status is known to us. Then we have to assume, we have to take the majority voting, we have to ask whether these are true or false. After taking the majority voting, we will come up with a conclusion. Okay? Now let us try how to remove this problem. So you can see here we have assumed that our k is equal to 3. Usually, in the k nearest neighborhood, your k will be assumed as a odd number. Can anyone tell me why odd? Correct. Say if I will take k equals to 4 number of nearest neighbor. 2 nearest neighbor are telling that my machine is faulty. 2 nearest normal.
50-50.
Then 50-50 probability is there that it is yes or it is no. So what decision we will take? We have to avoid such scenarios. We are taking a odd number. So two.
Some Twitter robota, so it's a text representation model. Base, sentiment, latest. I have talked about base and instruct, what kind of model it is. So this is base. So then you are using from.
I am not going to discuss the like what are the algorithm, how it is working and all. What I am trying to discuss is in AIML what are the different important components coming to picture, right? So the next
That rule can be represented as if-then statement, not else. If-then statement. If antecedent, I told you, if antecedent, then consequent. But antecedent, that means this is a function of attribute with operation along with values, and this is a end condition. Okay, this is an end condition.